Dear students, Unit 4, Multi-threading. First, in this unit, first we see about the introduction. The syllabus, JNTK syllabus is about JNTK syllabus is multi-threading, introduction, thread life cycle, creation of threads, thread priorities, thread synchronization, communication between threads, reading data from files and writing data to files, random access file. This is the syllabus. Now we see about the topics. First one, we see about the introduction. What is meant by thread? What is meant by thread? A thread is a program execution. Program execution. Thread means program execution. That is set of sequence of instructions execution. For execution, what is the set of sequence of instructions that we can call as a thread? A thread is a lightweight flow. It is a single flow of control, only one flow. It consists of single path. Because it is single flow, then it is called as a single path. Example for thread is main method. So the main method is known as thread. The program which contains main method is called single threaded program. Single threaded program. Then what is meant by multi-threading? Next one you see about the what is meant by multi-threading. Multi-threading means actually the meaning of multi-threading is two or more threads that can execute concurrently. Two or more threads that can execute concurrently are called multi-threading. In multi-threading, every thread is a lightweight flow and there is more than one thread. So there is because of there is a more than one thread, then it is called multiple flows of control, and it consists of multiple paths of execution. Because multiple flow of control means multiple path of execution. That is separate path for each thread. Separate path for each thread execution. Example for multi-threading is one main thread remaining other threads. One main thread is required remaining other threads. So the program which consists of main thread and other threads, then that program is called as a multi-threaded program. So here in multi-threaded program, we required about the one main thread is required, remaining or other thread, that is user-defined threads. Let us consider a multi-threaded program which consists of a main thread and other three threads ABC. A main thread and other three threads ABC. The main thread which starts other three threads ABC using start method. So the main thread which start the other threads ABC by using the start method. Once initiated by the main thread, the threads ABC can run concurrently. Once initiated by the main thread, the threads ABC can execute concurrently. Here, all threads run on a single processor, and which thread is executed first depends upon the operating system. So most important one is all threads can run on a single processor. That is number one. Number two is which thread is executed first. We cannot decide, but who can decide? Decided by operating system. Operating system. For example, say A B C is there. A B C is there. So which thread is going to be executed first? So A thread or B thread or C thread? We don't know. But sometimes in output, sometimes first A thread is executed first, means after some time C thread can execute first or B thread can execute first. So which thread start execute first, that we cannot decide. It can be decided by the operating system. Decided by the operating system. See here, there is a main thread. One is main thread. Then how many threads are there? Three threads are there. Thread A, thread B, thread C. So main thread can make start thread A, or main thread can start thread B. Main thread can start thread C. So main thread to start thread A is going to be thread start method. Main thread to start B is going to be start method. Main thread to start thread C is going to be the start method. So there is a switching between thread A to thread B or thread B to thread C, and switching between thread C to thread B or thread B to thread A. In concurrent execution, that is in parallel execution, there is a switching between thread A, thread B and thread C. So in parallel execution, there is a switching between thread A, thread B and thread C. The main advantage of multi-threading is we can divide a large program into different threads. The main advantage of multi-threading is we can divide a large program, big program, into different threads and execute them in parallel. so that the execution time will be decreases. The main advantage of multi-threading is the execution time will be decreases. Because see, one thing I will tell you, that is total burden is you put about the main thread, then execution time will be fast. Sorry, execution time will be more. But whenever we are going to create some threads, thread A, thread B, thread C, then thread A can execute something, thread B can execute something, thread C can execute something. Automatically, the main thread burden will be decreases. Okay, so actually, the main thread should execute all the things, but only one thread, main thread executing about all the things means it will take more time. But whenever you create your own threads, thread A, thread B, thread C, in that thread A can execute something, thread B can execute something, thread C can execute something, then automatically what happened, the burden on main thread is going to be decreases. Okay, because it going to be carried by the work or the burden of main thread can carry by thread A, thread B, thread C. Automatically what happened, the main thread burden will be decreases, so the main thread okay, so it will take less time execution. And one more thing, how whatever maybe threads you're going to create, but all threads should execute by the main thread only. Without main thread, there is no execution of thread A, thread B, thread C. This is very important point. Okay, without main thread, thread A, thread B, thread C cannot be executed. Okay, so whatever maybe threads you create, all the threads can execute by the main thread only. This point you should be remembered. Now thread life cycle. Thread life cycle. During the lifetime of thread, there are different states. That states are given by number 1 newborn state, number 2 runnable state, number 3 running state, number 4 blocked state, number 5 dead state. What is meant by newborn state? When we create a thread, the new thread is born and is said to be newborn state. When we create a thread, the new thread is born and is said to be newborn state. By calling start method, it can enter into runnable state, or by calling stop method, it can enter into dead state. Very important point. By calling start method, it can enter into runnable state. By calling stop method, it can enter into dead state. Runnable state. What is runnable state? In this state, the thread is ready for execution and is waiting for availability of processor. In runnable state, what is meant by runnable state? In this state, the thread is ready for execution. The thread is ready for execution and is waiting for availability of processor. Waiting for availability of processor. See, then third one is running state. In this state, the processor has given time to thread for its execution. Okay, in this state, the processor has given time to thread for its execution. So by calling suspend or sleep or wait method, it can enter into blocked state. That is paused state. PAUSED, paused. Blocked state means paused. By calling yield method, it can enter into runnable state. By calling stop method, it can enter into dead state. You can enter into dead state. Blocked state means sometime it will take rest. After that it going to be continue. That is called as a blocked state. By calling suspend, sleep or wait method, it can enter into blocked state. By calling yield method, it can enter into runnable state. By calling stop method, it can enter into dead state. See here in this diagram, you can clearly observe about the diagram. In this diagram, initially it is in new thread, that is newborn state. Newborn state. From this newborn state, it can enter into active thread, that is by calling the start method, it can enter into running state. So from running state, by calling yield method, it can enter into runnable state. So then next one, by in newborn state, by calling stop method, it can enter into dead state. That is called killed thread. Then in active thread state, that is running or runnable state. So if you call suspend, sleep, wait method, it can enter into blocked state. From blocked state, okay, suspend method is there, then it's going to be resume method to call to make into runnable state. Sleep method by calling about the notify method. After sleep method, by calling about the sleep means sometime it's going to be sleep, then wake up automatically. But when it is in wait state, by calling notify method, it can enter into again runnable state, from block state to runnable state. So in blocked state, if you call stop method, it enter into dead state, that is last killed thread. Then in runnable or running state, by calling stop method, it can enter into dead state. By calling newborn state, if you call stop method, it can enter into dead state. So blocked state means what is meant by blocked? In running state by calling suspend, that is in running state, running, in running. Okay, in running state by calling suspend or sleep or wait method, it can enter into blocked state. If we use suspend method, then call resume method to enter into runnable state. If we use wait method, then call notify method to enter into runnable state. If we call sleep method, then it can sleep sometime, which is mentioned in sleep method, and then enter into runnable state. But by calling stop method, it can enter directly into the dead state. Now, what is meant by the dead state? Last one is what is meant by dead state? A running thread ends its life when it has completed its execution. A running thread ends its life when it has completed its execution. It is natural death. By calling the stop method, also it can enter into dead state. Now programs. Now here programs. In this programs. So I going to be write about two programs. From the two programs or one program, we can derive all the number of programs because for a student, what is the difficulty in Java programming? The difficulty is writing the programs. Okay, writing the programs. So what he feel is he feel very difficult. Suppose by learning two programs, okay, if you write about the maximum number of programs from that, then you feel very easy. So that one I going to make it here. You carefully listen about these programs, how I have written, so that you can easily learn about all the programs. Okay. So creation of threads. Now create a child thread using thread class. So we can create threads by using thread class or by using runnable interface. We can create a thread by using about the thread class or by using about the runnable interface. Okay, that is the most important. So if you know about one program how to write for the thread class, one program about how to write about runnable interface, that all the programs, that two programs going to be used for writing the all number of programs, so that you feel that the programs are very easy. Now creating child thread class using thread class. The main thread and child thread is created by extending thread class. Here initially, that is, I am taking the only one thread, creation of one thread, and there is a main thread. Okay, child thread. So the main thread and child thread is created by the extending thread class. Extending thread class. That is the main thread and child thread. Both can be created by extending the thread class. See, class A extends thread, just you write. So wherever you write class A extend thread, for all it is common. Then public void run try for int I equal to 1, I less than or equal to 10, I plus plus sleep 1000 system dot out dot println child thread plus I, child thread plus I. Now what you have to write, catch exception E system dot out dot println E. This is common. This is one thing you remember, all of you. First you remember about this one. So this part of this, that is class A extends thread, this one going to repeat maximum number of times. Maximum number of times. Only this code, that is class A extends thread public void run try for int I equal to 1, I less than or equal to 10, I plus plus sleep 1000 system dot out dot println child thread plus I catch exception E system dot out dot println. This code, what is the meaning of this code? This code is class A can run every 1000 nanoseconds sleeping. After 1000 nanoseconds sleeping, it going to be print I equal to 1, I equal to I equal 3. I equal to 1 to I equal 2, it going to sleep about 1000 nanoseconds. I equal 2 to I equal 3, it going to be sleep about 1000 nanoseconds. I equal 3 to I equal 4, it going to sleep about 1000 nanoseconds. Like that, it going to be sleep about the 1000 nanosecond for printing about the I equal to 1, I equal, that is child thread 1, child thread 2, child thread 3, like that. Okay, that is the meaning of this code. Now here you can see about the direct thread demo, public static void main string arguments a1 equal to new a object is created, a1 dot start. Automatically what happened, the thread A is going to be started. Okay, so after starting that thread, okay, after starting that thread, here also I am writing about for int j equal to 1, j less than or equal to j plus plus system dot out dot println main thread plus j. That's all. That means up to this is common. A1 equal to new A1 dot start is common. But what I added here, just to remember, for j equal to 1, j less than or equal to n, j plus plus, system dot out dot println main thread. So this is the child thread, this is the main thread. Now go for the creating child thread using runnable interface. Runnable interface. How to write the program? The main thread and child thread is created by implementing the runnable interface. So for that, how we can write? Class A implements runnable. Class A implements runnable. Then this code and the top of the code is same. That is public void run try. So we have to write about the try catch block, because sleep is nothing but some gives about some runtime error. If it cannot sleep about the correct time, whatever the time is given, then automatically runnable error is going to be execute about exception. Because of that reasons, sleep we are writing try and catch only. So try for int I equal j, I equal to 1, I less than or equal to I plus plus, thread dot sleep 1000, system dot out dot println child thread plus I. Then catch exception is system dot out dot println is common. Now in this, that is class runnable public static void main a1 equal to new a, but don't write about the a1 dot start. Because of runnable interface, the interface cannot be executed directly. That interface should be taken in a class, then execute that class. Okay, so the interface cannot execute directly. The interface cannot execute directly. What you have to do, take that interface into a class, then run that class. Automatically it's going to be executed. For example, thread t1 equal to new thread a1, then t1 dot start. It's going to be started. So remember, extends class means directly a1 dot start. Implements runnable means create the object first, thread t1 equal new thread t1 dot start. So this a1 should take in the thread class. Now here you have tried about the main thread for int j equal to 1, j less than or equal to j plus plus, system dot out dot println main thread plus j. Now next, creating multiple threads using thread class. Creating multiple threads. All code is repeated. Remember, all code is repeated. Very easy about the threads programs. Generally, thread programs are very tough. In general, normal says threads programs are very tough. So that one I am making about the very easy by considering about the only one. See here, class creating multiple threads means a multi-thread program is created by extending a thread class. See previous, like in our previous, what is there? Class A extends thread public void run try for int I equal to 1, I less than or equal to I plus plus sleep 1000, system dot out dot println good morning. What I am giving here, good morning plus I. Similarly, I am taking about the second, then catch exception is common, then class B extends thread. Public void run try for int j equal to 1, j less than or equal to j plus plus, sleep 2000, then system dot out dot println hello. So there good morning, here there is a hello plus j. So catch exception, then system dot out dot println e, this one. Similarly, I am taking about the class C. Again class C extends thread public void run try for int k equal to 1, k less than or equal to k plus plus, sleep 3000. Then system dot out dot println welcome plus k. Okay, good morning, hello, welcome plus k. Then catch exception is system dot out dot println e. Now in main function, that is class thread demo public static void main string arguments. So here, because I am taking about the 3 threads, create the objects for 3. That is a1 equal new a, b1 equal new b, c1 equal new c. Then call this directly a1 dot start, b1 dot start, c1 dot start. So when you go and write about a1 dot star, when there is a extends thread class. When you can write about the b1 dot start directly object through object directly, when you can write this one by extending the thread class. Now see the next program, that is creating multiple threads using runnable interface. A multi-threaded program is created by implementing the runnable interface. That is class A implements runnable. Again, same code is going to be repeated. Public void run try for int I equal to 1, I less than or equal to I plus plus, thread dot sleep 1000, system dot out dot println good morning. Catch exception is system dot out dot println e. Then next class B implements runnable, same code. Public void run try for int j equal to 1, j less than or equal to j plus plus, thread dot sleep 2000, system dot out dot println hello plus j. Then next class C implements runnable, public void run try int k equal to 1, k less than or equal to k plus plus, thread dot sleep 3000, system dot out dot println welcome k. Then again Catch exception is system.out.println ending. So, but because of it is interface, remember. So class runnable demo, public static void main string arguments. First create objects a1 equal new a, b1 equal new b, c1 equal new c. But here what you have tried, you cannot write the directly. When implements runnable interface, you cannot write directly a1 dot start, b1 dot start, c1 dot start. So this a1, b1, c1 you have to take into a thread class. So through that thread class it should be start. That means thread T1 equal new thread A1. A1 is taken in thread T1. Thread T2 equal to new thread B1. B1 is taken in thread T2. Then thread T3 equal to new thread C1. That is C1 is taken into thread T3. Then we write about the T1 dot start, T2 dot start and T3 dot start. Then next program, thread priorities. See here, one important point is which thread is going to be executed first. If you create about 3 threads, that it cannot be decided by ourselves. It can be decided by only operating system. Which thread can execute first cannot be decided by ourselves. It can be decided by our operating system. But we can give priority to the operating system, saying that please execute first this thread, then second this thread, third this thread. Either the operating system accept or not accept, that is secondary, but we have to tell the operating system or compiler what are we going to tell means I am giving this is highest priority, this is lowest priority, like that is the middle priority, like that we can tell. Okay, either it consider or not consider, that is secondary case, but we have to tell. Then we are giving the priority, that is called as a thread priorities. How is possible we see? In Java, each thread is assigned to a priority. To set the priority, we use set priority method. General form syntax is thread name dot set priority number. Set priority number. Which number? Minimum priority equal to 1, maximum priority equal to 10, normal priority equal to 5. Minimum priority is 1, normal priority is 5 and maximum priority is 10. Default is normal priority. So if you are not given about any priority, but it's going to take about the normal priority. Now see the program. Class A extends thread, public void run, same thing repeating. Try for int I equal to 1, I less than or equal to 10, I plus plus, sleep 1000, system.out.println good morning plus I. Similarly, catch exception is system.out.println e. Next, class B extends thread, public void run, try for int j equal to 1, j less than or equal to 10, j plus plus, sleep 2000, system.out.println hello plus j. So catch exception e, system.out.println e ending. Then class C extends thread, public void run, try in this for int k equal to 1, k less than or equal to 10, k plus plus, sleep 3000, system.out.println welcome plus k, common, up to this common. Now priority demo. In this priority demo, first you create the object. That means up to the top, no need to write. First, if you learn initially, that is okay. Just you can learn only about the public static void main. For every program, just you learn about the public static void main, that's enough. Automatically, you can write about the every program in very simple manner. Very simple matter. A1 equal to new A, B1 equal to new B, C1 equal to new C. Now, I am giving the priority, maximum priority is for C1. How I can write that one? C1 dot set priority, thread dot max priority. Max all are capital letters. Max priority is all are capital letters, underscore max priority in between underscore. B1 dot set priority, thread minimum priority. That means I am giving maximum priority is C1, minimum is B1 and normal is A1. Normal is A1. Now C1 dot start, B1 dot start, A1 dot start. That means I want to start first C1 by giving the maximum priority. I want to start B1 by giving the minimum priority. I want to execute A1 by giving the normal priority. Next, is alive and join methods. Is alive and join methods. The syntax for is alive method is final boolean is alive. That is what is meant by is alive. When a thread is waiting for join, then is alive returns true, and after join there is no that thread waiting, so is alive returns false. Is alive means the meaning of that one is when a thread is waiting, that is called as a is alive. When it's going to be join, then it's going to be join. So there are two methods here. Is alive is nothing but the a thread is waiting for join. A thread is waiting for join. That is called as is alive method. Is alive is nothing but a thread want to join, waiting for join in a thread, So is alive means a thread want to join in running state. Is alive means a thread is waiting for waiting some time, okay, for joining into the thread, another thread. Now in that case it is called as a is alive. Join means it going to be joined in that, okay. So when a thread is waiting for join, that is called is alive, and it returns true. And after join, there is no the thread is going to waiting. At that time, is alive is false. Very simple manner. When the thread is waiting for join, then it is alive is true. After join, there is no thread is going to waiting. At that time, is alive returns false. Okay. The syntax for join method is final void join throws interrupted exception. See why is alive there is no throws exception. That is, there is no exception. Final boolean is alive. So either is waiting, that's all. It is not going to be joined. But in case of join, there should be some exception, because join means it should want to join compulsorily. Sometimes it's going to miss in that in joining, it's going to miss, okay, slip, it should miss. So that's why whenever it's going to be slip, whenever it's going to miss, it's going to throw the exception. That's why we're writing about the interrupted exception. Somebody want to join, but he cannot able to join. He going to be slip, okay, or it going to be he cannot going to be join because of he cannot run properly. So like that problems are there. If that problems occur, it throws the exception. For that purpose, I am writing about final void join throws interrupted exception. Now see the program. Class A extends thread, public void run try for int I equal to 1, I less than or equal to I plus plus, sleep 1000, system dot out dot println good morning plus I. Now catch exception. Now here it is catch exception E system dot out dot println E. See here, class A extends that public void run try for int I equal to 1, I less than or equal to I plus plus, sleep 1000, system dot out dot println good morning, and catch exception E ending. So this one is same previous. Similarly, you see the class B extends thread public void run try for int j equal to 1, j less than or equal to j plus plus, sleep 2000, then system dot out dot println hello j. Catch exception is system dot out dot println second one. Similarly, what is the third one? Class C extends thread public void run try for int k equal to 1, k less than or equal to 10, k plus plus, sleep 3000. So system dot out dot println welcome plus k, catch exception, then system dot out dot println e. Up to these three same repeated. So where here you should be changed. E is alive demo public static void when string args a1 equal new a first object, then b1 equal new b second object, then c1 equal to new c third object. Then first you start these threads, because is alive joining means already three threads are started, then it's going to be is alive and join. Now see, in this case you just see about this. A1 is started, B1 is started, C1 is started. Now after starting A1 dot is alive. That means A1 want to join again. B1 dot is alive. Then B1 want to join again. C1 dot is alive. Again C1 is going to be joined. Waiting for join. So actually A1 is started, B1 is started, C1 is started. Now A1 dot is alive means A1 is waiting for join in the running state. Then B1 dot is alive means B1 want to join in running state. Then is waiting for join into running state. Then C1 dot is alive. C1 is waiting joining into running state. So in this case, system dot out dot println A1 dot is alive means it print about true. Then system dot out dot println B1 dot is alive means it print about the true. Then system dot out dot println C1 dot is alive means it print about the true. Then try A1 dot join, B1 dot join, C1 dot join, catch interrupted exception E, system dot out dot println E means already three are joined and running. Now again if you ask about the A1 dot is alive means already it is joined. Then B1 dot is alive means already it is joined in running state. C1 dot is alive means already C1 is joined. So again joining means there is no person is going to be waiting. So in this case, in this second case, it going to print about the false. That is A1 dot is alive false, B1 dot is alive false, C1 dot is alive false.